So we're doing a little, what's called the Transformations Homework Quiz. You will get the benefit of a partner. That means that last hour, I thought everybody's going to finish and then we were going to grade it, but nope, there was like 4 groups that just couldn't finish it. So I didn't want to like make them have really bad grades and force them to grade it. And so anyway, bottom line is, hopefully by the end of the hour, we'll have everybody done and I can grade it with you in class and you'll see how you did. Otherwise, if not, I have a backup plan for that. So I think 80% of you are going to know that it kind of looks like this. Raise your hand if you knew that. Okay, good. Then, if you didn't know that, here's how you could have figured it out. You could have made an XY chart, couldn't you? Stick in 0, see what you get. What if I put in 0? Square root of 0 is 0. If I put in 1, the square root of 1 is 1. If I put in 2, nobody knows the square root of 2. It's a decimal that goes on forever, never repeats. Kind of a weird thought that nobody knows what it is, at least as a decimal. You can go about what it is. You could round it, but nobody knows what the square root of 2 is really equal to as a decimal because it's never ended. All right, so back to, if I put in a 2, it's not going to work. 3, it's not going to work. What's the next number that works? 4, and the square root of 4 is 2. Some poor kids think there's 2 answers to the square root because your teacher messed you up. Nope, square roots have only 1 answer, so the square root of 4 is just 2. If nothing else, this symbol right here means the principal, as in positive number. You can't come out of a square root anything other than a positive number. The principal root, which is the positive root. So it's a positive number. All right, and last but not least, you could put in 16, but what's the problem with that one? Goes off. So what else could even fit on the graph? 9, and that would give you 3. Square root of 9 is 3. So there's a bunch of points, and you would have graphed these points, and I can't think of a single kid in here that wouldn't have been able to connect those dots and go, oh yeah, that's what the graph looks like. All right. Now how about if I asked you for the domain and range of it? Would you please right now write the domain, what the range? So on domain, you're kind of asking yourself a question. How far what? How far to the left? And how far to the right does it go? Does it go forever to the left? No. Because if you put in negative numbers, it won't exist. If you put in like -1, it won't exist. So it's 0 to infinity with a bracket and a parenthesis. Range, how low does it go? 0. To how high does it go? Infinity. Same answer, which is kind of weird, but true. All right. Now, let's see if you can handle it if I go this way. Would you agree that the parent of this was a square root? It's just been flipped and moved. Now, I could have told you that with words, or I could tell you with this picture. And either way, you'd know that the parent was square root of x, but it's been moved to the right. How far was it moved to the right? Be careful, is it the 3 or the 2? The 3. It's been moved right 3. And then how far has it been moved up? 2. See what I did there? And you might be like, but it's upside down. It's not normal. Normal would be like this. Yeah, normal would be like that. This isn't normal. It's been flipped. So, what do? A negative on the outside. And there, I have just created, given the graph, I have created an equation. There's only one other form that even exists for this, and that would be the XY chart. This is in terms of a picture. This is it in terms of an equation. And then you could make an XY chart. We already did this before, though, but like I could put in a 4, and then it would work pretty good. Square root of 1 is 1. Then you make it -1 plus 2, which would be 1. And you could find some points on it. Those are the 3 major forms. The graph, the equation, and the chart. All right. So one more that's kind of weird is, what's the domain and range of this? What's that question about domain again? Nobody has a short-term memory? question you ask yourself about domain.
Left
Yeah, left to right. How far to the left does this thing go?
3.
It starts at 3, touches 3, and how far to the right does it go?
Infinite.
Infinite. Now, a lot of people mess up the range, so don't say it. Don't tell anybody the range. Check, and then in a second, I'm going to see if your answer is right. I'll tell you, a lot of people mess up the range. The range is how low to how high. So negative infinity to how high does that go? Careful, it's not the 3, it's the 2 bracket. Does that make sense to you? Okay, it's how low to how high. All right, and the one that most kids had trouble with last hour, I can't give you too much help with it, otherwise, you know, like they got kind of, that wouldn't be fair. If I give you this function, would you know what that looks like? And then if I told you that it needed to move to the right and down, would you be able to adjust the 1 over x function to go to the right and down? Let's say it was right 2 and down 3. If it was that, then people were like, but how do I graph that? And I'm like, how do you graph everything? How do you graph something like this? Play connect the dots. Make some points. Now, if I were you, do you remember that the graph kind of looks like this to start with, and it has asymptotes this way and this way? Wouldn't the asymptotes move to the right and down also then? And then they were like, but how many points do I have to have? These are the only 2 normal points on the whole graph. All the rest of them are weird decimals. So all I really need is those 2 points to move with your graph. This is not the same question, so don't copy this down as like, ooh, this is the answer to the hard one. It's going to be similar to this, but I would move the asymptotes right 2 and move the asymptotes down 3 or whatever, wherever you're moving. And everything moves with the asymptotes. All right, without further ado, you're going to have this little quiz. I'm going to pair you with somebody. I get to pick who that is. It's usually in rows 1 and 2, the person across, but sometimes there's people absent and I got to move them around. So don't move yet. But after we are done with this quiz for today, the only thing that is the homework is if you don't finish this thing, I hope as a class we can just get done and then nobody has homework. This quiz is it. All right, so do your best to try to finish. And that's all I have for the video for today.